Okay, hey everyone. Going to be getting started here in just a minute. All right, great. Today we're going to be getting started with the hottest new technology in iOS 11, which is ARKit. And I'm definitely not anywhere near an expert in this yet. It's really interesting, but it's also not something that I normally deal with. So I'm going to go ahead and get started. I'm not going to be walking through a lot of the theory and the high-level stuff. The WWDC video does a really nice job at that. I'm going to get into some more of the practical, like how do I get my feet wet with this thing. So going back here, there is a template for an augmented reality app, which is, it's good. It definitely gets you, well, you know, let's do it real quick. Let's check it out rather than me tell you about it. So we're going to pick augmented reality app. And I'm also going to be sharing my phone today because one of the things that makes it a little bit harder to demo is you can't use the simulator. So I've got this thing called Reflector 2, so I can actually share my screen with you guys. See if we can get that going. Yeah. Okay, sweet. Here we go. And let's run it. See a cute picture of my son there in the background. And from the, you always have to give it permission first time. Just by implementing the template, you get this 3D in real space. You can see my office, and there is now a rocket ship in here. It's pretty damn cool. Practicing this in the coffee shop at night, everybody kind of looks at you weird because you know, you're doing this a lot, but so it's pretty fantastic. So we're going to be doing something similar to what's going on here, but basically it's a SceneKit implementation of using ARKit. And this is something that you have to kind of get used to. There's the augmented reality, the ARKit part of things, which is like the world tracking. It knows, it understands your 3D space. It can help you detect planes. It can help you detect when things collide in the real world. Your virtual items collide or hit a plane in the real world. ARKit doesn't actually render. It doesn't actually render that spaceship I just showed you. You use either SceneKit, which is Apple's main 3D framework, SpriteKit, which is the main 2D framework, or you can use Metal to roll your own rendering engine, which is totally beyond me. I've never had to do that before. This demo was done with SceneKit, so that we're going to start off with SceneKit as well, but we're going to just build it up from scratch. And luckily there's not a ton to build up, so I'm going to trash that. Start a new project. Again, you have to be working with Xcode 9 to get this to work. And, okay, well, we'll get into it, but you need, at least for iPhone-wise, you need an iPhone 6S or better. Anything before that, you can't use the world tracking, which makes the experience pretty lame, but we'll show you. So, we're going to do a single new application, and we're going to call it AR Test 101, whatever. I'm going to put it in my normal Study with Adam directory, so we'll upload this to GitHub later. Okay, so this is just a plain old application with nothing exciting going on. Now, what we're going to do is we're going to stick something called an AR SCN view on top of our view controller. AR for augmented reality, SCN for SceneKit, and view is just the UI view subclass. So what that is AR SCN view knows how to do a lot of things and does a lot of things for you. It takes the camera image, it takes your 3D models, and it handles the lighting, and it puts them all together and puts them in the 3D space for you. So it's pretty fantastic. So let's get started. We're just gonna dive in here. Get rid of this, and let's make a scene view. Oh wait, so we have to import. There's a couple things you have to import. You have to import SceneKit. In this case, because we're going to be using SceneKit to do our rendering, and we're going to import ARKit, because that's going to be our ARKit. So this is going to be of type ARSCN view. Now, you could totally do this in the storyboard as well, but I'm just going to choose to do this in code. And the first thing we're going to do is we're going to set that scene view to a new instance of ARSCN view. We'll just give it the frame of our views frame. Okay. And now, one of the things we're going to do here is we're going to set this ARSCN view has a delegate which gets a lot of callbacks, which is really important. So we're going to make an extension on view controller, and it's going to support the ARSCN view delegate. Let's go ahead and we're going to take a look at what's in this delegate. So they're all optional. So we have looks like they all start with renderer and node for anchor. Automatically added to the scene graph. If the method is not implemented, the node will be automatically created. So this is to provide a custom node called when a new node has been mapped to the given anchor. So one of the problems here is that you need some knowledge of SceneKit to really make progress here, right? So for me in my learning of ARKit, it's been like 75% learning about SceneKit, 25% learning about ARKit, because you have to learn how to create these 3D models and then put materials around them and manipulate things in 3-dimensional space, transform things. So it's not something that I work with on a day-to-day basis. So the bigger challenge for me has been understanding SceneKit. So I think once I get past my 101 kind of knowledge, I may take a step back and dive deeper into SceneKit. So we'll see, but our job is just to get things going today. So there's these nodes, SceneKit nodes and anchors, and basically SCN scene view will map nodes and anchors for you. So let's get back to the view controller and let's continue our setup. So for view to load, we're going to do a couple things. Of course, we're going to have to add our scene view. Add subview, scene view. All right. Now we're going to do a few more things in the view controller lifecycle to manage the session, and the session is very important. So we have what's called super on view did appear. and we are going to create a configuration, AR world tracking configuration. Now, there's two different types of configurations, world tracking and orientation tracking. AR world tracking can literally track the entire world that you're in three-dimensional space. But the problem is that you need the device needs to have, like I said, it's like the A9 chip. So it's iOS. So it's the iPhone 6s and above, and more modern iPads. If people don't have that, you can either choose to not let them use your app, or you can provide kind of a reduced experience and give them orientation tracking. And I'll show you in a minute, once we get started, the difference. But we're going to start with the world tracking configuration. And essentially, we create a session, and we start a session with this configuration. So our scene view has a session, so you can see that it has an AR session, and we're going to run it every time the view did appear. I think there's a helper method. Run configuration. Yeah. Cool. Okay. And you can also pause your session, and that's what we're going to do when the view does disappear. So every time this view disappears, we're going to pause it because this is a resource-hungry thing, this session, right? It's tracking the entire world. So if you're going to pop up another view controller, or if you're going to go to the background, we want to be pausing our session. And when it comes back, it's not a big deal. You can just fire up your session again with this configuration. So the first thing we want to do, let's make sure that it builds. Also make sure I'm still sharing. It looks like I'm still sharing, okay. Okay. Oh. Okay. So this is something that the default template provides that we're not providing, is you have to give a camera usage description if you're going to be using this thing. So to do that, we go to our info plist. We're going to add a new key. Privacy camera usage description. Yep. And we'll just give it we need to see your stuff. Okay. Let's try it again. So again, the built-in template automatically adds that key for you, but we're building it up from scratch. We need to see your stuff. Wait, you guys can't see this yet. This is unfortunate. Here. Let's try this one more time. Sorry about this, guys. I'm going to pull up Reflector. Here it is. I can never find things in the stock. Okay, let's try it again. There we go. Finally. You guys don't need to see this full screen. Okay, so let's go back to it. All right. So what we did here was we started a session, we added our screen view, and you know that we added the screen view because it's rendering the camera's output, which is part of what ARKit does. It takes the camera session, the motion tracking, puts it together, adds intelligence to it, and then allows you to render your virtual content on top of this real world stuff. So it's doing the first half right now. It's rendering the real world. Now let's add some virtual content. And we'll do the simplest thing that we can to get started just to demonstrate how it works. We are going to create a scene. So let's scene equal. Okay, this is a SceneKit scene. And we're gonna add, let's add a really simple, so now what we want to do is we want to create a geometry. Let's do one more thing first. Before I forget. Scene view, the scene views scene, it has a scene property, is going to be our scene, okay? Now, let's build something up and put it in our scene. So the way you do this is you're going to create a geometry, which means it's going to be a box or a cube or a Pokemon or whatever, and we're going to add that to our scene. So we'll do the simplest thing is we're going to add a box. So we're going to say box equals a SceneKit box with some simple dimensions. And these dimensions are in meters, so you want them to be pretty small. And their chamfer radius is, if you want to make it a little bit rounded, but I don't, so we're going to call that 0. Now we're going to give our box a material so it actually looks like something. So material, okay, and the way you create a material is, as far as I know, remember this is far from the definitive SceneKit tutorial, is you have this diffuse property, so an object that manages the material's diffuse response to light. So when light hits the material and diffuses off of it, what do you see? That's how I take it. Anyways, and so the contents of that can be many things. They can be a UI color in our simple example. So we'll go with brown. So now we have a shape and a material. And with those things, we can now create a node. So node equals SCN node. And one of the initializers is a geometry. So what shape should our node be? And that shape's going to be a box. And our nodes, geometries, materials, you give it an array of materials, equals material. Okay, so let's review very quickly. We create a scene. We create, you know what, just making things a little bit more logical. Okay, so we create our box shape. We create our box's brown color. And we create a SceneKit node, and we initialize it with the shape that it's supposed to be and the lighting color that it's supposed to be. Then we add, so the scene, our scene has a root node. and we can add a child node to it. So we can add child node to the scene's root node. So it's kind of like the view controller. View controller has a root view, and you can add subviews, thus forming a tree. So this is the same kind of a concept. So we'll add our node to the scene's root node. And I believe that's all we have to do. So let's check it out. Let's see if it works. I know what I screwed up. Hold on. Okay, I screwed something up. Our node also, so our node needs to have a geometry, which is the box. Our node needs to have materials, which is the material. But our node also needs to have a position so it knows where to go. So let's fix that. No, don't crash. It's going to crash. Oh, it didn't crash. Okay, so position equals, and it's a 3D thing, so it has to, and it's going into a 3D world, so we need to position it in 3 dimensions. So vector 3. So SceneKit vector 3-dimensional, SCN vector 3. And we're going to put it takes 3 things, an X, a Y, and a Z. And these, again, are in meters. So we'll put it, X and Y, we'll put it right in front of the camera. And this is in respect to the camera. And then in the Z position, we're going to push it back a little bit so we can actually see it. Negative 0.5 meters. Okay. Our scene view gets the scene. All right, guys, I think we should be good to go here. Let's try this. Oh, okay, we have a box. And you can see as I'm moving my phone around, the box stays in position. I'm moving it back. I'll move it underneath. Very, very cool. So it started off half a meter from my camera in, you know, the virtual thing in my real world. There we go. Very cool. Okay. So the next thing I want to show you is what happens if we don't have world tracking. So the reason we were able to move the camera and keep the box in perspective and in the same place in my room is that world tracking was enabled. And I have an iPhone 6s, so that worked. When I tried this on my older iPad this morning, it didn't work. And you can get a way crappier experience by doing AR, let's see, configuration, orientation tracking configuration. So when your view appears, you start your session with this thing called orientation tracking configuration. And the difference is just what it sounds like. Instead of tracking the world, all it does is it tracks the orientation of your objects. And I'll show you what I mean by that. We're going to push it back just a little bit farther so it's easier to see. Did not need a new tab. All right, let's check this out. Okay, we still have a box in my room, but you can see as I'm moving, the box is moving with me. It looks like it's staying 0.7 meters away. And you can kind of see that it's 3D, but, you know, not really. So coming back, it's tracking with us. It's not doing the world tracking. So I don't know. It doesn't really seem very cool if you don't have world tracking. And from what I saw from the WWDC video, you can actually prevent people. So in the App Store, you can, I don't know if you can prevent people or if they won't see it, but you can make sure that the people who download your app have world tracking. That's going to be an option. I'm not sure how to do that yet, but I know you can do that. All right. So let's see what else we got. There's different types of materials. So we will create. So you can basically just like just grab a JPEG or a PNG or an image file. I got this little pattern of camouflage. And instead of the material being a color, you can give it an image name. So the pattern is, for me, is called camo, right? And let's get our crappy orientation tracking on. We'll go back to world tracking for the rest of our days. Okay, we've got our camouflage box here. Oh yeah. So our box is now wrapped in camouflage. It looks pretty awesome with very, very little work. And notice now I'm pulling back, and it's not pulling back with me, it's staying where it was. We can zoom right up on that sucker and pull back. So that's just, you know, so you can kind of get to see the different possibilities for textures or materials. That's that. What else can we do today? One more thing I'd like to do today is be able to select one of our items. So to be able to select our box. Okay, one more thing I want to show you guys is that we can add another item, right? So I like this one. We're going to create a torus. I don't know the technical definition of a torus. But there is an SCN torus. A torus or ring-shaped geometry. Okay. So, you know, we're going to do that. We are going to, oh yeah, I have this other thing, this other material, which I called shear. I was having a lot of fun with this. So, we're going to create a new shape, a new geometry, with a new material. This one's going to be called shear. And we're going to create a node based on that geometry. We're going to give that node an array of materials. We're going to set that position. And then we're going to just add a new child node to our root node of the scene. Torus node. All right, let's check that out. So basically, as you can see, it's like a tree shape. We can add multiple nodes to our root node. Woo! Okay, that's kind of a big boy. Let's dial that back a little bit. 1.2. All right, let's try that again. Okay, so there they are living next to each other. We have this awesome thing called a torus. It kind of looks like a blimp. And then we have our camo box. Kind of zoom in here and it'll fly through the intersection. Oh, that is so cool. Yeah. All right, and we can even do, and you can kind of intersect, which is cool too. So let's look at that. Maybe if I do this, let's just kind of see what happens. They kind of like, they can intersect with each other too, which is cool. Okay, so there's our blimpy torus thing. Oh, I think it's swallowed. Yeah, it swallowed our box. Oh, it's not let that happen. I just want to show them intersecting, but I'm pretty sure it swallowed it. There we go. So we can kind of like come around the back side here, over the top. And do you see that? The torus is in the process of swallowing our camouflage box. I don't know. I just get such a kick out of it. And then it's weird. Once you start looking at this for a while, and then you look in the real world and it's not there, it's very disconcerting. It's a little strange. So, just to show you can make an entire scene of different objects, we're going to do one more thing today, though. We're going to add a tap gesture recognizer to the scene, and we're going to get a hold of a reference to our virtual object in the real space coordinates. So let's do that right now. We're going to start by adding tap gesture recognizer. First, let's add the handle that we're going to call. So, at objective C, private, func, handle, tap, gesture recognizer, UI gesture recognizer. Okay. Now, we're going to have a tap gesture recognizer. Tap gesture recognizer equals UI tap gesture recognizer. Target is going to be self. Our actually is the selector for the thing we just made, which is handle. Yep. And now we're going to scene view dot add gesture recognizer, tap gesture recognizer, and let's just double check that that works before we go too much further. Okay, so I'm just going to tap on it. Okay, cool. So we got that. All right, let's keep moving. Okay, so there's some pretty cool stuff we can do here. We're going to get a hold of the recognizers. Just recognizer. So we can guard, let, let's call it the scene view. Guard, let, scene view equals recognizer dot view as SCN view. Else, let's bail because something weird happened. Then we can get the touch point where the person touched. So let's say let touch point equal recognizer dot location in the scene view. So in its coordinate space, let's get the point where the person touched. Now we can do some hit testing. Okay, so now we can say let results equal scene view dot hit test. Yeah, and here's our method. We're going to pass in a point, and for now we're not going to use any of these. We're not going to worry about the options. Shoot. Okay, so let's talk about this real quick. This is a method on SCN view that you give it a point. It then passes back all of the points of interest that intersect with your touch. Okay, so you're touching the screen, and if it is an SCN view that you're touching, it can come back and give you points of interest. Things like nodes that you've added, planes that have been detected. We haven't gotten to planes yet, and there's anchors as well. So it gives you back an array in this results thing here, an array of hit test result. Hit test result Detailed information about a result from searching for elements of a scene located at a specific point or along a line. Segment. Ray. Okay. So, and it's an ordered set of things too. It's an ordered array. So the first thing is going to be the closest thing to you. And the last element in the array will be the farthest thing away from you. So if I had my box here and then I had a plane over there, it would give me this object that's very close to me. So we can get a node. So let's say let node equal results dot first. Let's make sure there's something in there. Dot node. Else, again, let's just bail for now. And let's just say, so what we're trying to do is we're trying to intersect with the closest node that I'm touching in three-dimensional space. That's what I want back. And let's say as a goal, let's change its material. All right, so let's say let material equal SCN material. Material dot diffuse dot contents equals, well, let's just give it a color. And then let's take our node here and let's change its geometry's material. Node dot geometry dot materials equals, and we'll just give it a whole new array. We'll reset its array to this cyan color. So let's run this guy. And we'll make some predictions about things that can happen. Okay, so if we touch anywhere on our scene view, this handler should get called. We already proved that. But if there's not a node there, because all we're looking for is nodes right now, nothing should happen. So let's try it out. I'm going to tap. Nothing happened. Now we're going to touch the camouflage thing. And there we go. Turn to cyan. I'm going to touch the other thing. And it turned to cyan. Sweet. Let's try something out. Let's go with the last. So that would be the farthest away. Let's run it again. We'll try to do another prediction. So now we have some points here that we have our blimp and we have our camouflage box. And I can see a place where I could touch the screen, and in theory hit both. So I wonder if I can just get the box to show up. It to turn blue and not the blimp. No, because I think maybe the blimp's farther back. So why don't we move our blimp up a little bit. Make it a little bit smaller. And let's move our box back a little bit. See how that looks. Oh crap, I don't think you guys can see it. Sorry. Take my word for it though. The wrong thing turned blue. See how this looks? Okay. The box is clearly behind. That didn't work. Okay, so my expectation there would be that let's get a count. Let's see how many things do come back. Let's just print results.count. Let's see what comes back. What do we get? We got 1. Ew. That's why. No, man, this thing's gonna crash on me again. Please don't crash. Okay, let's see if we can fix that. Let's not shift things around so much. So let's just say this is 0. We'll even move it up a little bit. And all right, see what happens now. Oh my goodness, it's a giant bloat. Can we still see our box? Yeah. Okay. So let's. We're only getting one thing back. That's crazy. Let's make a bigger box. All right, buddy. Let's make you big. Now you're going to have a giant camouflage box. I mean, this is just fun to play with, right? I really enjoy this. Hey, you. Okay, now if this doesn't work, I don't know what's going on. We have our smallish blimp with a sheer fabric. Oh, that's what makes it a Taurus. It's got its little hole there. Hey, buddy. Okay. And then now we are totally... Wait. Oh, I'm sorry, guys. Here, let me give you a little tour again of our Taurus. There's this little hole. Now, when I press in the middle here, we should really get two things back, because clearly there's two things. Ah, why? Result scene view dot hit test at the touch. Oh, I wonder if the touch point. Oh, maybe the touch. Maybe okay. So it's not. It's a point in space. It sees that I'm trying to touch closer, and I'm not trying to go farther back. Oh, okay, I get it now. So my assumption is that this hit test is a 3D hit test. And it's thinking that I'm touching the closer thing. So that's probably what's happening. But anyways, we were able to grab a node that we touched in 3D space, change its material. Very cool. That's it for me today. Everybody have a good weekend, and I will see you on Monday if you're into it, and we will do more studying iOS. Thanks.